Hello, everybody, and welcome to today's Kong webinar. Thanks for joining us. We appreciate it, and thank you for folks joining us from all around the world. We're joined on this webinar by my colleague, Aaron Miller, Senior Solutions Engineer, and I should mention that my name is Cooper Marcus. I'm the Principal Product Manager here, and we couldn't do this without the help of our very talented and smart customer success engineers and sales engineers who are staffing the question and answer feature. We might have been joined by our CTO on Q&A. Let's see. We've got a nice series of webinars that we present. The next one will be coming up in January. Stay tuned for the topic and date. We'll be putting that on our webinars page on our website. I think that's all the intro. Aaron, what do you think?
Yeah,
anything?
That sounds good.
All right, let's get started.
Okay, thank you, Cooper. As you can see, up on the slide, I'm Aaron Miller, Senior Solutions Engineer, and Cooper was introducing us. Because we're going to be demoing Kubernetes today, as probably most of you know, Kubernetes is going by its nickname of K8S, so we're following that convention. You can call me A3N and C4R.
I'm C4R. Nice, I like that. And I'm a
Star Wars.
I'm a P. What is that? P17R is my title. All right.
Excellent.
Nice.
And yeah, we just rebranded as Kong, so K2G might be a little soon, but let's get right into it. So, let's lay out some history of where we are and why we're talking today. So. A long time ago, let's say by long, I mean 10, 15 years ago, APIs really started to take off, and we knew API gateways started to take off, and what we saw is that they bumped along for quite a while. You can see 2008, 2010, 12. Things didn't really take off until 2014, and you might ask yourself, well, what's so special happened in 2014? Well, one thing, and it's a big thing, Docker, right? So containers, I think, were that technical enablement piece that allowed APIs and microservices to proliferate. Now, keep in mind that that doesn't come without its own problems, and that's, again, why we're talking about Kubernetes today. And I'm just going to skip ahead in the deck a little bit to jump you into the Kubernetes slide. And Kubernetes really allows you to kind of logically orchestrate and maintain a large number of containers, right? When you're dealing with 5 to 7 containers, no big deal. When you're talking hundreds or thousands, then you really need to start thinking about Kubernetes, and that's one of its strong points. So, oops, let me go back. That should jump me back. Okay. And we were talking about Docker and how that really led to this proliferation of microservices. Let's move forward. So it helps to think of maintaining microservices and think of something very concrete. And I like to think of running microservices like you might run a city, particularly thinking of roads and streets and highways when you maintain all the traffic that you have to route when you maintain microservices and APIs.
We've got things like speed limits for that maps to rate limiting. We've got things like detours, right? As you're working on one road, you're going to detour the traffic to another road. That's maybe a blue-green deploy or canary deploy. Well, maybe a canary deploy. That would be let the pedestrians go down the road before you let the cars go down the road. How about that, right? We've even on the corner got a little map. Right? How do you understand the layout of your city? That's more about humans learning to navigate the city, move around the city. I think that maps to things like developer portals and documentation, also part of what we offer. I really like the city analogy. Almost everything you could think about in a city, you can think about mapping to running APIs and running microservices and managing APIs.
Exactly. Highways to handle more traffic, right? Expressways. You have all these kind of fertile kind of pictures in your mind. And speaking of pictures, let's have another popular one, right? So
somewhere in the city there's a chicken coop, and that chicken is thinking about, am I about to become McNuggets?
Right. And this is another way to think about your business, right? So think of your business as the chicken, and you need to basically deconstruct your business and make it a little bit more consumable for everybody. You know, McNuggets are a little more consumable than a live chicken, but you have to do that without killing your chicken. So you see this dilemma, right? And you can't just stop your business while you make your McNuggets. No, you've got to keep them both running and alive while you do this. So how do we do this, right? Well, one popular way, and the way we advise, is take the ice cream scoop approach to it, right? And this is a little bit more animal friendly. You don't have to eat the whole pint of ice cream or gallon of ice cream at once, right? Just scoop out a little bit of your service at a time. And that's a much more kind of maintainable way. So who are some other businesses that have taken on this challenge and successfully come out the other side? Uber is one very popular example, and they've faced the same problem. And I think we all have this problem of basically without ongoing maintenance, you end up with a monolith. Not by design, but just by the nature of doing your work. And then it comes time to realize that, wow, that one little change that I had to make to the payment system, that took way longer than I thought it would have. And that's because you're running as a giant monolith. So let's see how we can break that down, right? So we all start with this one kind of image. We've got a bunch of different modules running inside of just one larger module, and that's a little bit too much. So let's go ahead and start picking that apart. So we pull out the items thing first. We add some logic to it, some security, some authentication, and we leave the rest of the monolith alone. We put a load balancer in front of it so that we can redirect traffic intelligently. And then we keep doing this, right? We keep on breaking little pieces, adding more logic. You can kind of see what's going on here. We're going to end up in a state, though, where I've got a lot of the same logic repeated. So I'm not being dry, right? I'm repeating myself over and over again. I've got the load balancer repeated as well. And from this, yep.
Let's just go back a slide here, Aaron, because I think this previous one, right. So it's important here to note that when we split out these microservices, we had the requirement that they have things like security and authentication and rate limiting. Of course, they need load balancing in front of them. They also probably need things like logging. And in the absence of a wiser approach, the teams that do the work to split out each of these microservices, they're just going to do these same consistent parts of logic again and again, but they're probably not going to do it consistently, are they? I mean, imagine here, look, You've got two teams. One built the item service, one built the customer's microservice. They each had to do security, authentication, logging, rate limiting. What are the chances they did it in the exact same way? And even if they did, they had to do it twice, and then 3 times for the third service, and 4 times for the fourth service.
Yep.
That sounds like a suboptimal approach.
Exactly. And the other danger that you run into then too is then you have more code to maintain, right? Mm-hmm. And somebody reports a bug on authentication layer, and you go, well, which team did this authentication, right?
That's right.
So anyway, yeah.
Or maybe now all the teams have to go and individually solve the same issue in 4 different ways, in 4 different implementations of authentication. Again, wasteful, inefficient, and perhaps worst of all, I bet one of those teams, despite their best efforts, is just going to get it wrong. There's going to be a hole, there's going to be an issue, and that just doesn't seem effective either.
Exactly. So I think we've realized this, and we've seen this pattern before, and you come up with what is historically known as the API gateway pattern. It's a fairly obvious solution in retrospect to put all of this logic into a single layer, and that's what has happened in the past. There's again some trade-offs that you're making when you do this, though, and that you have a fairly heavyweight solution just in front of all of your services, right? So solutions other than Kong, you don't get to pick and choose what goes into this layer, right? You just get everything whether you want it or not, and they weren't historically focused on performance either, right? It was a fairly heavyweight, a lot of latency, a lot of overhead to implement this feature, but that was okay because you front-ended it, right? So on the left side, you see kind of the historic, kind of older way to do it, and then you see Kong's more modern approach, in which breaks everything down. Kong becomes a microservice, basically. It sit along, next to your other microservices, and you're not paying the huge penalty of forcing all of your traffic right through that API management layer and then having to scale that way. So, I think this is a much more kind of lean approach to it. You've isolated a lot of your logic so that your teams don't have to worry about rate limiting, authentication, logging, and all of that stuff, yet you're not paying huge penalties in terms of overhead. So this is kind of more the picture that you're looking at with Kong, and I want to highlight in this picture the idea that Kong's architecture implements most of our functionality with plugins. So this doesn't force you to use transformations if you know you're not going to need them. You don't even need security if you don't absolutely have it, right? Logging, again, you have the flexibility of maintaining this. And the other advantage too is that because of Kong's architecture, you can develop custom plugins that meet legacy needs.
Now, I just want to interrupt for a second to remind everybody this webinar is being recorded. We'll be sharing the recording with you afterwards and posting it on our website. We also welcome questions at any time via the question and answer feature in GoToMeeting. You can ask questions about anything you're seeing or hearing from us or anything else Kong related. Just go for it. We'd love to see your questions there, and we'll try to get to them either live during the webinar or via the question and answer feature in GoToMeeting. All right, Aaron, go ahead.
Thank you. So just to kind of reiterate the facts that we're talking about teams that are developing similar logic across your enterprise and how that leads to a lot of duplication and potentially waste and side effects and errors, just a non-optimal type of way to do this. So it's another advantage of going with an API management layer is that you can consolidate a lot of this stuff. Keep in mind too that a lot of your traffic is not just going to be public traffic, right? Notice on the right side you have public traffic, you have partner traffic, you have internal APIs, which I think is a huge growth area that people are realizing, and these are all consumers of your microservice. So Kong, you have a couple deployment options. I would say most of the population at large is on the left side, but in order to kind of future-proof you to a not having to switch layers for your integrations, we want to be thinking about sidecar deployments and how you can do that in the future. So Kong definitely has that built into it.
And I want to talk about this slide just to clarify a couple things here. In the image on the left, what we see is a Kong cluster serving as the API gateway that has the unified functionality abstracted out from the individual microservices that we mentioned before: logging, rate limiting, authentication, maybe request and response transformations, other things like that. But don't be fooled. Just because we show all those Kong nodes next to each other doesn't mean they're running, for example, on the same machine or even in the same location. The nodes can be deployed wherever you like, and indeed on the right we show a diagram of deploying the nodes as sidecars alongside applications. And the great thing about Kong is that moving from the left to the right is very straightforward because the nodes are still talking to the data store, which we'll cover in a second. As long as the nodes can talk to the data store, their configuration stays in sync, their state stays in sync, and they're in a position to route, log, transform, authenticate, rate limit your API requests in a consistent fashion.
Exactly, exactly. And what you're saving on the right side is going out into your network. Even if it's your internal network, there's still a latency hit. So definitely some advantages to implementing more in that sidecar type solution. Moving on, and to kind of just reiterate, I'm going to hammer home a few points all the time, right? Keep in mind your clients can be any number of these: employees, internal systems, partners, any of those. Kong gives you the ability to load balance, service discovery, authentication. You can read through the rest of those, right? And then you can front end and proxy basically your private APIs, partner APIs, public APIs. And then the last one, again, is a kind of forward-looking statement, but a lot of people are getting excited about function as a service, lambdas, and so forth. And I think that's a very popular way to do it, because you talk about abstracting away the roots of what you need to run in code, and containers are being I think the first way to do that, really what you want to do is just run your function in the cloud somewhere and not care about any of the hardware. And I think that's what function as a service gives you, even more than a container.
We've got a few interesting questions on Q&A, so I want to address a few of those here live on the call. So there was a question about how administrators of Kong make their changes to Kong's configuration. We're going to cover that in a moment here in the slides, but effectively they're issuing commands to the administrative API that are then shared with all the Kong nodes regardless of where they are, as long as they're in the same Kong cluster. And what it means to be in the same Kong cluster is to be connected to the same data store. And so whether your nodes are deployed in a centralized cluster, in a distributed cluster, as sidecar proxies, regardless, if the nodes are connected to the same data store, then they'll be synchronized. Now, to allow you to do things like testing changes before they make it into production, you would follow the typical patterns that you would follow for any sort of test or development environment. You'd want to run a separate Kong cluster in a development or staging environment where you're testing changes in that separate Kong cluster. There's also options for doing blue-green, canary, and other sort of testing in a production Kong cluster, but the approach can be a little bit different. So both of these approaches are available. Let me just see if there's a few other questions here I want to be answering. So there was also a question about how requests are routed in centralized and decentralized structures. So the routing is effectively the same. Kong is configured where each API in Kong has a defined upstream, a DNS location to which requests will be routed, and your system takes care of responding to those DNS requests that Kong are issuing and then routing the requests appropriately. Potentially they're being routed to a container on the very same machine. Potentially they're being routed to an application that's elsewhere. Heck, potentially they're being routed halfway around the world. It's up to you to choose how you configure both Kong in terms of where it's routing and where you place your upstream services. Well, we're getting lots of questions here, so let me see if I can answer a few more of these. We've got, let's see. You know what? Let's take a few more steps through our deck, and I bet some of these are going to get answered.
Yep. So Kong comes in two major flavors, right? So we're showing you today the Community Edition. It's the most popular open source API gateway in the world. Over 4 million downloads. Open source. You can go check us out on GitHub. Built on top of Nginx, and we'll talk about the architecture in a little bit more detail. Tons of plugins out there contributed by the community and by our own Kong teams. Sub-millisecond latency for most use cases. So we really believe in having minimal overhead for your proxy APIs, and we deliver on that. Cloud native, platform agnostic. Of course, we're going to be focusing on the Kubernetes deployment here, but you get to choose, right? So as I've said on other webinars, we've even had somebody spin up Kong on a Raspberry Pi. Not that I'd recommend that for a production deployment. And again, very fast, very scalable. I believe the current record is 200,000 requests per second. So really, I think the Kong Community Edition has exceeded our wildest expectations, and that kind of led into people that run very large enterprises, and they had different needs, right? So they had all of those same needs that the community had, but they also have very stringent SLAs with their own customers, and that kind of led to a natural progression into the enterprise product. So we have a number of Fortune 10 accounts. That large e-commerce customer in Japan is the one that I was talking about that delivers just huge throughput. Many major banks, telecommunications, Australia Postal. So there's really no industry that can't benefit from what Kong has to offer, and we're really seeing that. But what the enterprise product lets you do is deliver all of those functionalities plus some, right? And we have an amazing customer success team that is just there around the clock and able to bring you expert help in record time. So, I love to, have the dynamic tension between the community and the enterprise product. I think that keeps them both healthier. So, just really quickly on because we're demoing CE, I'll just touch on Kong Enterprise really quickly. Security, high availability, the admin that somebody asked about, a developer portal product, analytics, and professional support.
And indeed, right, we had a question about an admin UI. That is part of Kong Enterprise. Our admin UI has role-based access control for controlling who can do what to administer Kong. That also applies to the admin API. The admin UI is expanding with additional analytics and monitoring features. We demoed some of that in last month's Kong Enterprise webinar. There should be a recording on our website at konghq.com/webinars. And in the future, there will be more demos of Kong Enterprise. Probably there'll be another one in January or maybe February. Stay tuned to konghq.com/webinars and also to your email where we'll let you know about future webinars.
Thank you, Cooper. And again, going back to the plugin architecture, you have a number of plugins to select from. I'll be demoing the keyauth one today, as well as the rate limiting. So those are probably the two most popular ones, and then followed by OpenID and the rest of these. So we mentioned there's 60 to choose from. This is just a small selection of them. And then to touch on serverless, we have Lambda and OpenWhisk currently, and more going all the time. So because we're plugin powered, and because Kong has an emphasis on speed and simplicity, and you'll see this later on, really it's very easy to configure. So I'm going to be running some command line demonstrations of this, but really all it is you hit 3 endpoints, you hit 2 ports, you have a proxy port and you have an admin port, and then you just supply some config parameters to your plugins or your consumers or your APIs, and you're up and running in no time. We're going to be focusing on the Kubernetes installation today, but as you can see, we support quite a wide variety. Docker is probably the easiest to set up, DCOS, Miso, Google, just go on and on here.
Just want to step back a slide, if you will. So we got some questions about the administrative interface to Kong, interacting with it via an administrative API or administrative UI. To reiterate, we have already released some time ago an official administrative UI as part of Kong Enterprise Edition. The community has also released some open source alternative UIs that run on Kong Enterprise or Kong Community Edition. They're not built and supported by us, and they don't have the extent of functionality that we have, but they're good, and we encourage you to try them out. Our community is large and vibrant and growing, and part of the value of choosing an open core product like Kong is that dynamic community that can produce interfaces and plugins that suit your use case, and so we encourage you to check those out. We also had some questions about speed. Why is Kong so fast? And Kong's so fast because we made it fast from the very beginning. We knew that you should not have to pay a latency tax. That when you bring all of that functionality from all of your microservices or from your monolith into a new layer, a new step in your request and response lifecycle, the last thing you want to do is have to make a trade-off where you're thinking, well, I get all this centralized functionality, but it comes at the cost of lots of latency. That's a terrible trade-off to make. So from day one, we've built Kong to be extremely performant. It uses caching to cache many configurations in local memory. It's built on top of Nginx, which already has extreme performance. It's extended with Lua, which is a high-performance scripting language, and we build and maintain it for maintaining and improving performance all the time.
Thank you. Yes. So touching on that, as Cooper just said, Nginx, basically a web server written in pure C, so about as fast as you can get. However, because C is not very easy to extend, we've layered on top OpenResty, which is the Lua layer that we're talking about, and that's where you would be writing plugins. So that's how you would customize and configure and basically talk to Nginx under the covers. For clustering in the data store, we offer 2 choices, either Postgres for simple single data center deployments, or data center wide deployments, or cross data center Cassandra. Plugins are the way to augment a lot of Kong's abilities, and then to interface with it, an admin API, and then one not shown here, the admin GUI, is for the enterprise product.
Now, those two data stores are the two data stores we support today. We don't have any near-term plans to add support for additional data stores. We did get a question on the webinar about support for Postgres clustering, replication, sorry. My understanding is that's a relatively new feature, part of Postgres 10, I think it is, and stay tuned. We're looking into it. We're definitely checking it out. We see some opportunities potentially to allow our users in the community and our enterprise customers to scale Kong on Postgres. Normally, scaling to any sort of geographically distributed deployment of Kong has typically, if not required, at least encouraged the use of Cassandra, and we understand that some folks are more comfortable with Postgres. Great, we're looking into it, stay tuned. We had another question about swapping out the underlying Nginx on which Kong is built with other web proxies, and the answer is no. Kong is tightly coupled to Nginx and is highly dependent on it. Zero plans for allowing you to use anything other than Nginx. But really, why would you? It's highly performant. It's easy to install and run. We think it's a great choice. And frankly, the world agrees. Something like, what, half of the internet is served by Nginx, or half the website? So we're not the only ones that are betting on Nginx.
Probably just the fast websites.
There we go.
And as I said, Kong is very simple to use and administrate, right? So we're just looking at 5 ports here. Really, for the CE edition, we're just talking about 4, and really 2, because 2 of these are your SSL ports. And the endpoints here I'm going to be demonstrating are just 3, APIs, plugins, and consumers. And it's very simple to set those up and administrate them and modify their behaviors from the command line. Of course, there's a GUI as well in the enterprise product. So we're getting near the demo stage. What I want to lay the groundwork for is there's a very popular web service out there called HTTP bin. It's at httpbin.org, and just lets you inspect a lot of the common HTTP commands that you're going to have. But it runs, just as a normal web service, unprotected. We're going to front end that with Kong, and we'll implement some rate limiting and some authentication if there's some time.
Now, of course, you're going to have a service, a microservice, or an application that does more than HTTP bin, right? But we're just using it because it's handy for demo. It effectively echoes back portions of your request or tells you things about the request you're making to it. So you'll see in our demo that as we make requests to HTTP bin, the responses we get back have to do with the requests we're making. We're not getting back weather data or stock prices. We're just getting back information about our requests. But in the absence of Kong, well, as Aaron mentioned, anybody can use it, and they can use as much as they like. So we're going to add Kong and then quickly add rate limiting and authentication, so only authorized users can use it only as much or as frequently as we permit. These are very typical use cases for implementing Kong, are rate limiting and authentication.
Exactly. So going back to Kubernetes, I'm just going to touch on this slide, right? So you remember at the very beginning, we were talking about the rise of microservices and how this kind of created demand for administrating them, and that's exactly where Kubernetes comes in. So I'm going to be running Minikube, which is a local deployment of Kubernetes to demo this, but it works functionally the same as a large deployment of Kubernetes. And I'll just about to go into the demo time. Before I do this, let me tell you what you're going to see. So I've installed Minikube already, so you don't have to watch me do that. I'm going to be walking through the install of the database. Inside of that, run the migrations to prepare the database, install Kong, and then I'm going to proxy the HTTP bin, set up a rate limiting, and if we have time, I want to leave time for questions at the end. I'll show you how to do auth and apply a different rate limit to each one of those. All right.
So as Aaron is getting set up with his demo, I'm going to see if I can address a few more questions that are coming in. Thank you for the questions. Please keep them coming. Also just note the webinar is being recorded. We'll be sharing a recording with you afterwards and also placing it on our website. Let's see. There was a question about highly availability and leadership election. There is effectively no leadership in Kong. All of the nodes are the same. The nodes will route traffic upstream. and if a given Kong node goes down, well, hopefully you've got other nodes. It just depends on how you've deployed and architected your Kong cluster. But there is no leadership node. Any node may be contacted on either the proxy port for proxy requests or on the admin port for administrating Kong. And the nodes use the data store to synchronize their configuration.
Yep. And just so you can follow along at home, I'm just going out to the main Kong website. I'm clicking the install Kong guide. I'm scrolling down to Community Edition, clicking that installation guide, clicking on Kubernetes. I'm going to walk through this README because I am doing the local install, and that's just going to dump me right into our GitHub repository, which I've handily already set up for us. You'll see that here. As soon as I cd into that, you'll see that I'm running all the same stuff, right? So to run Minikube, you just do a Minikube start, and once you've started Minikube, you get a little bit of lag for your VMs getting set up, and I'm ready to jump into deploying Kong. So I'm going to just clear out my buffer there and just do a kubectl create. And I'm creating the database.
Folks, we hope you can see the terminal windows here just fine. Let us know in Q&A if we need to zoom in any further. We want to make sure you can see lots of information on screen, but also have it be actually readable. So, yeah.
Let me just show you my Minikube dashboard really quickly, so that will kind of give us a better view into what's going on inside of my Kubernetes cluster. So you'll see I've deployed the database already. Switch back to my terminal, clear this out, and I'm just going to do another kubectl command. And this is all listed in the README on the inside the repo. I'm going to do a migration of Postgres. I have a choice of Postgres or Cassandra, as you know. Run that. And that's running my migration. So this takes a second or two. Let's go ahead and check on the progress here.
So the migration, Aaron, my understanding is that's getting your Postgres database set up to use with Kong.
Exactly. Yep.
Right.
So we'll go in and take a look at the logs and just see what it has to say. So it ran 45 migrations. And that's because I started with a bare install of Postgres, so I had to prepare it for Kong. Switch back. So now I'm 2/3 of the way through my deployment. Run another kubectl create, and this is where I'm going to create the actual Kong nodes, right? So Kong on Postgres, or I would do Kong on Cassandra. And we've set this up to do 3 Kongs, and then it notice it sets up a few services. So we can inspect those with kubectl get service, I think. And there they are. So because I'm using Minikube, I'm just going to take a nice advantage of it and say Minikube service list. And this kind of spits it out in a nice format. I'm going to do a little bit of shorthand to make my commands a little bit cleaner.
So let's see what we're looking at here. We see different port numbers that are mapped to Kong's 2 admin ports, a non-SSL admin port and an SSL admin port, plus 2 more that are mapped to Kong's proxy. So you're using the admin port for administering Kong. The proxy port is where Kong proxies API requests to the upstream service, in this case, HTTP bin. We also see there Postgres running, and of course the Kubernetes dashboard that we're using in this demo to show you what's going on with Kubernetes.
Exactly. And because we're on Kubernetes, I have to do something a little bit kind of more, laying some groundwork than I would normally do, right? If I'm not doing Kubernetes, I'm doing, say, Docker, my proxy would run on port 8000, and my admin would run on port 8001. But because of Kubernetes' kind of distributed nature, we've got to do a little bit more. So I've done that. Now I can run a command. I'm running a tool called HTTP Pi, and I can do something like this: admin, and I'm just going to hit the admin port, and it's going to return back to me that I'm running Kong and I'm running 0 to 11.2. I can actually set up an admin port. Yep.
So HTTP PI is an alternative to curl. You've certainly heard of curl for running HTTP requests on the command line. It can be a little ugly, so we use HTTP PI, and we encourage you, if you haven't tried it out, you should. It's a great command line tool for HTTP requests.
Yeah, think of it as a modern, friendlier curl. So you're noticing I'm not passing in a lot of arguments here because HTTP PI has a lot of built-in assumptions. Notice that it's going to know to do a post request if I pass it arguments. So I'm just going to set up an API endpoint. I mentioned that I was going to be front-ending HTTP bin, and that's what I'm doing right here. So I pass in a few arguments to the Kong admin, and it requires, well, let's just try it without the required arguments, see what Kong admin has to say. Okay, good.
Now, so, did we already try to make a request to HTTP bin?
Directly raw?
Yeah. Let's try it. No, well, through Kong. Let's try to ask Kong. I mean, we haven't configured anything, so let me guess, it's not going to work. But let's just have a look, right? So because we have Kong running, but it's not yet configured for any proxying, right? So let's confirm that by trying to get it to proxy something.
Yep.
All right, there we go. So we tried to make a request to HTTP bin, but no, Kong's saying, hey, you haven't configured Kong's proxy yet. So let's do some Kong proxy configuration.
Yeah. Whereas if I hit that endpoint directly with the same arguments, that's the answer I expect to get. So let's set up the proxy. $admin APIs. I have to name it, of course. So I'm going to call this demo. I have to give it a URIs command or a method. So I'm just going to be a transparent proxy. And upstream URL, you can probably guess, is going to be HTTP. You have to give it the protocol, httpbin.org.
So what Aaron has just done is configured Kong to proxy requests that come in to that particular API endpoint to upstream to HTTP bin.
Yep. Now when I hit it, instead of saying no API, I'm going to get a response. Notice too that I get a couple things, right? So it now has my origin IP added in because I'm of course proxying. So this is the real IP that's I'm eventually hitting, but this is the Kong proxy. There's a couple other things. Kong proxy latency of 111. I said sub-millisecond response time for most use cases. We can still do that, but notice that we're actually going through a few Kong nodes here, so it takes a little while to warm up the cache. I can actually show you what's going on in the logs of my different pods, so let's do this.
Now, the reason that we had a latency imposed by Kong of over 100 milliseconds was that on this very first request, the Kong node that received this request had to ask the data store, hey, what do I do with this request? And that request, that data store interrogation takes a little while. But the next time that Kong node receives a request with the same routing rules, the Kong node will not have to ask the data store. Instead, it refers to its local cache, and the Kong latency will be much lower. Now, in this arrangement, we have, Aaron, what, 3 Kong nodes running?
Correct.
And we have a Kubernetes load balancer in front of them. So as we're making requests to Kong in this demo, Kubernetes load balancer is spreading them out across the 3 Kong nodes. So we're going to need to warm up all 3 nodes and before we start seeing consistent sub-millisecond latency, or at least latency that's a lot lower than 111 milliseconds.
That's right. So let's hit that endpoint again and see what happens when I do that. So I hit the proxy port, and I'm going to use IP again. And Kong proxy latency is still pretty high. You saw, I don't know if you saw that, it happened really quickly, but in the upper left-hand corner, I hit my proxy, and it logged it. I'm going to hit it again. Kong latency dropped dramatically down to 19 seconds. I'm going to hit it once more. I'm at 49. I'm just going to keep hitting it a few times, warming up the cache. There, Kong proxy latency got to 0. You'll notice I'm in the upper left-hand corner. So again, I'm going to have to warm up all of these caches on my 3 pods, and eventually I'm getting to 0 overhead because Kong has cached all of these responses in all of these areas.
So those three boxes at the upper part of your screen and the one on the left, those are three Kong nodes running in our Kubernetes cluster.
Yep.
And our lower right box, that's our terminal where we're interacting with the Kong nodes via Kubernetes load balancer.
Yep. And just to show you what that looks like inside of my Kubernetes dashboard, right? Here you actually see the three Kong nodes that I'm actually talking to. And I'm actually going to delete this because the migration is already done. So I don't actually need to keep it around. It's not going to do anything. And the interesting thing about Kubernetes is that I can actually go in, and this is kind of dangerous. I wouldn't recommend this, but it's part of the nature of a container management system where containers are intended to be ephemeral, right? You don't want to worry about your hardware. And notice that immediately Kubernetes detects that and spins up a new one. So no matter what, I'm going to be running three Kong pods.
I've got a few questions here on the chat I wanted to address. One is a question about the local cache and how TTL is managed. So we use multi-level in-memory caches in each Kong node. There's a cache at the worker level. There's typically as many workers as you have CPU cores. There's another cache at the node level, and then we hit the data store. These caches, there is, for the most part, little control over them directly, but there doesn't need to be. Kong's taking care of that automatically and doing cache eviction as you create new updates, new configurations via Kong's admin API. We also had another question about availability zone aware routing. Now, in this configuration, we've got three Kong nodes, but, well, they're all in the same availability zone. Heck, they're all on your laptop, right? But what if they were in three different availability zones all around the world? Sure, no problem. You can use DNS to configure different Kong nodes to route to different upstreams depending on their location. You can also use service discovery tools like Console to manage these distributed nodes and the routing thereof.
Yep. Okay, so you've seen the front end, you've seen the proxying behavior of Kong. Let's move next into rate limiting. So you want to protect your service to a certain extent, and very easy to do. So I'm just going to set up HTTP, hit the admin port, and for this I'm going to apply a global plugin and a global rate limit. So it's very easy to do, and just name it rate limiting. So this is built into Kong. So what I'm doing is, if I can spell limiting, and I'm going to configure it to be per minute. I'm going to do 7. So the arguments are HTTP to call my administrative interface, set up the plugins. I almost made a mistake. So the actual, when in doubt, it's pluralized for most of your endpoints. Admin plugins. Give it a name of rate limiting, which will tell it which plugin to configure. And then I'm going to say you're allowed to call my service 7 times a minute. Now, let's hit our endpoint again. Very easy to do. Clear this out. And what I want you to notice is that we now have 2 new headers, right? So this is because I applied the global rate limiting plugin. And if I hit it a few more times, you're going to notice it's counting down. Kong is automatically synchronizing the rate limiting across all of my nodes. And as soon as I make this next call, boom, I'm rate limited. So I get a 429, which is the HTTP response for you've exceeded your rate limit. And now I have protection for my service. Now, unless I wait another minute from the same IP, you're going to be rate limited.
Now, there's a lot of configuration available for rate limiting, plus we've been working hard on some improvements that we'll be releasing in future versions of Kong Community Edition and Kong Enterprise Edition, allowing additional configuration. And in this case, we're configuring it to rate limit based on an IP address, but it could also rate limit it based on a particular consumer.
API.
APIs, that's right. Yep. It could be globally applied, can be limited to particular APIs. Pretty much anything you could think of with regards to rate limiting can be achieved And even in our Enterprise Edition, we have a feature that allows you to place a limit not on the number of requests, but on the rate of requests, which is an interesting approach. Sometimes you want people to make steady flow of requests. But anyway, let's do that one later.
Like almost like acceleration of my requests. So, interesting. Okay.
Yeah. So let's see. We've achieved part of our goals here in the demo. We deployed Kong on Kubernetes. We configured it to proxy API requests upstream to HTTP bin, and we're seeing the response of those requests as we go. In this case, we're just seeing it echo back the origin IP address. And now we've added rate limiting so that we can't call HTTP bin too many times. But we still have no auth, right? Anybody can call it, whether or not they're allowed to.
Do we have time for auth?
Well, I don't know. Let's see. Yeah, I think we have time. We seem to be moving along nicely.
Right. Let's keep going then. Let's do that. So to do that, we're going to implement the auth plugin. Very simple to set up. See, mem usage? Sure. I think.
We'll take a quick break here. We got a question about CPU and memory usage for the Minikube Kong pod. Let's have a peek.
I did find an area that talks to memory, so hopefully this addresses that particular question. Okay, I'm going to jump back into the authorization piece. So let me do this. HTTP, I'm going to hit the admin port again. And we're going to set up a few things first. So I need to hit add a consumer and call it a username, and we'll call this person Gold.
So a consumer is an abstract concept in Kong. It can represent a particular person, it could represent a partner, it could represent a team, or it could go all the way down to representing an individual instance, say, of a device. It's really up to you. And consumers are an entity to which we can attach things like credentials, and also that we can consider for purposes of usage tracking. See how much a given consumer is using, at least in Kong Enterprise.
Yep. So before I hit enter here, you're going to notice I've done one thing already. I've set up a consumer. I've named it Gold Partner. And now I'm about to assign that Gold Partner a key. So that's its authorization key. So now when I hit the endpoint again, without a key, notice, and this is because actually I didn't set up the key auth plugin. So this is actually expected behavior. So let me go ahead and do that.
So let's see, you set up the consumer. So the consumer exists as an entity in Kong's data store, but we haven't told Kong what to do with it.
Correct. You'll see.
Got it. Okay.
Yeah, exactly. So you'll see that there's the Gold Partner.
Now also you gave this consumer a pretty low security password of gold. If you don't specify, Kong will make up a higher security one for you, or you can specify. It's up to you. But we're using a nice easy one like gold to make it easier on Aaron as he types these commands.
Exactly. And also clear so I can remember them. So now I'm going to set up the key auth plugin, and now I have authentication. So let's hit that endpoint again, and oops, no API key. So let's pass that in. The only API key I have now is gold.
So previously when you hit this endpoint without an API key, Kong said, sure, go for it. We had rate limited the request, so sure, go for it, but not too many requests. Now Kong is saying, hold on, we need to see your authentication before we let you pass.
Yep. Notice I'm still rate limited, of course, but I need that key. If I pass in an incorrect key, then it says invalid authentication credentials, and if I pass in no key, then it says no key.
Now, remember earlier in the presentation, we showed you how in the absence of a centralized piece of functionality like the Kong API gateway, you would have your individual teams building rate limiting and authentication independently as they spill out microservices from your monolith. Now we've shown you in just a few minutes how you're running authentication and rate limiting at a central, controlled, and performant location, the Kong API gateway, and you can now free your development teams from having to build that independently. You can tell them, hey, don't worry about rate limiting, don't worry about authentication. You can assume that every request you can receive is both authorized and there's not too many of them.
Yep. So now I'm setting up another consumer so we can actually see this in action across two things. So now I've got a different key, and I'll pass that in, and you'll see both of these in action. And great, so now I have free and gold as my keys. And now I'm going to do one last thing. So you've seen that I have a global rate limit. What if I want different rate limits for my free users and gold users? And that's, again, different from the default rate limit. Very easy to do. So I'm just going to do that right now. Admin, and hit the consumer's endpoint. Give it the free user, and say plugins. My terminal's wrapping. And I'm going to name it rate limited. So it looks a lot like what I was doing before, but I'm going to specifically configure my free user.
So now we're getting set up to allow two different types of users to use our upstream at different rates, right? We've got a gold partner who can use a lot,
yep.
And a just general public who can use less. Or did we configure them to use more? 10 per minute?
10 for more than my default.
Okay.
And then I'm going to just set up my gold partner. To use a different rate limit, 15 per minute.
There we go.
Okay, so now when I use that key that we had before, free is going to be 10 per second, now 9, and gold is 15. And that concludes my demo.
So let's see. So you've made here a request with the key of the gold partner, and you're seeing that you've got a rate limit of 15, and you've got 14 requests remaining. And that let's make a request with the free, so as the public user, and you can see that this user only has a rate limit of 10, and they've got 8 remaining.
Exactly.
Yeah. Really cool, Aaron. Great.
Yeah.
So in just a few minutes, we deployed Kong into Kubernetes. We configured it to proxy an API. We added authentication for users, and we added rate limiting with different rate limits for different types of users. And did this all in a few minutes. This is a great demonstration of both the power and the efficiency of Kong that you can get going with it just like this. Now, we're running a cluster of 3 nodes running on your laptop. If we were running a global cluster, the commands you'd be issuing to the Kong admin API, they'd be exactly the same. I mean, hopefully you don't give somebody the password gold, but other than that, right, the general commands, they're exactly the same. And Kong takes care of synchronizing those configuration changes across your global cluster. It's amazing. I think one of the best parts about it is that when you learn to use it at a basic level on your local machine, and then you start taking it into dev and staging and all the way into production, and then you scale up your usage, everything you learned from the beginning, it remains applicable all the way through.
And that's what I like about Kubernetes too, right? All these mini-kube commands that I'm running, the kubectl commands, work exactly the same whether I'm talking on my local instance or whether I'm talking to AWS's Kubernetes or Google's Kubernetes or anybody's Kubernetes, basically. kubectl runs the same everywhere, just like Kong. So
we got a question about how Kong is identifying the consumer that's making the request to the API. Kong identifies the consumer based on the credentials that accompany the request. So in this case, the credential you supplied was the API key. One of them was the API key with the string of free. The other one was the API key with the string of gold. The free and gold correspond to 2 different consumers in Kong.
So yeah, to answer the user's question, you take 2 steps. You define the consumer's name, which I'm doing here with the username, and then I assign that username a key. And if I don't supply one, then it generates a much more secure key for me. And then I'm allowed to use that. Okay.
Let's see. I'm having a look here at some other questions. There were some questions earlier about the pricing for Kong Enterprise. We encourage you, please get in touch with us. You can see our email address there at the bottom, sales@konghq.com or konghq.com/enterprise. We'd love to talk to you about your use case and about the pricing for Kong Enterprise. Aaron, I think we'll wrap up the spoken part of this webinar. We'll leave the Q&A feature up for a few minutes to try to finalize all the questions.
Great.
Sound good?
Yeah, absolutely. I hope people found this valuable. We're definitely seeing a large uptick in Kubernetes, so I'm glad to be able to show that to you today, and hope you're joining the Kong community sometime soon.
All right. Thanks very much, Aaron. Thank you, everybody, for joining us. Special thanks to our customer success engineers, our sales engineers, and even our CTO who joined us for Q&A live during the webinar. We look forward to having you with us again in January for future webinars. Thanks, everyone.
Thank you.